Look at the scale of a modern cargo ship. In December of 1978, a state-of-the-art vessel, built much like this one, the massive, steel-reinforced MS München, was hauling cargo across the dark Atlantic. Somewhere in those freezing waters, she vanished. There was no distress call, no radio transmission, and when search teams arrived, they found 0 survivors. They did, however, find a piece of evidence floating in the debris. It was one of the ship's steel lifeboats, and it was completely mangled, beaten out of shape by an incredible physical force. That damage was a technical impossibility. On the München, that specific lifeboat was originally secured 65 feet above the waterline. A regular storm swell doesn't reach that high. For that steel to crush, a wall of water had to strike the ship from a height previously thought impossible. Surviving sailors had whispered stories in harbor taverns for centuries. They spoke of 100-foot vertical walls of water and terrifying holes in the ocean that appeared out of nowhere. The official scientific stance of the era dismissed these accounts. To them, these stories were hallucinations or exaggerations brought on by the chaos of a storm. This bell curve shows the mathematical basis for that skepticism. Based on standard linear models, a 100-foot wave should only happen once every 10,000 years. Because the math said these waves couldn't exist, the maritime world was left unprepared for a reality that science claimed was impossible. That changed on New Year's Day, 1995. The Draupner oil rig was standing in the violent waters of the North Sea during a severe storm. The rig sensors were recording a consistent baseline for the storm, with peaks hitting roughly 39 feet. Then, the rig's laser sensors recorded a single anomaly. Out of the chaos, a solitary wave emerged, proving that the linear statistical models used to predict the sea were completely inadequate. This chart recreates the laser data recorded by the rig. You can see the steady baseline of 39-foot swells, followed by a sudden, jagged vertical spike reaching 84 feet, a moment of wonder. In a fraction of a second, the sailor myths became an undeniable scientific fact. The rogue wave was real. How does the ocean concentrate its energy into a single point like this without an earthquake? It's driven by a mechanism called constructive interference. Imagine a fast-moving ocean current traveling in one direction, only to be hit by a powerful opposing wind. The water is trapped in a physical bottleneck. The regular waves are squeezed together and begin to stack on top of one another. The central wave absorbs the kinetic energy of the waves around it, stealing their power to grow into a vertical wall. This creates a towering crest of immense pressure, capable of exerting enough force to snap a steel ship in half. These waves aren't supernatural. They are the result of ordinary oceanic forces, compounding into a singular anomaly. Today, satellites scan the surface of the sea from orbit, providing a global count of how often these waves actually occur. We now know they aren't rare anomalies. They happen far more often than previous mathematical models suggested. The current estimate is that 10 of these giants could be active in the deep oceans at any given moment. Humanity has reached the moon and conquered the skies, yet we remain at the mercy of the ocean's unpredictable power. Welcome to Plain English. If you want to uncover more of the world's terrifying mysteries, hit subscribe and suggest our next topic in the comments.